Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. This video will review cycloalkanes, which is a special group of alkanes. Cycloalkanes are organic compounds where the carbon chain forms a cyclic structure or a circular type structure. And you can see some examples here on the slide. Essentially, these are formed, or you can think about them as taking a straight chain alkane and you're just connecting one end with the other end is what we're doing. When you do that, you'll notice that the second part of this definition is that you're eliminating two hydrogens from the straight chain alkane due to the combining of the end carbons. So if you look here, this is cyclopropane, and you'll notice the molecular formula for that. There are 3 carbons and there are 6 hydrogens. But if you had just a straight chain propane, you're going to have, you'll see here, if you add in your hydrogens around, you'll see you have C3H8. So you'll see the cyclopropane will have 2 less hydrogens than the straight chain propane. So that's one unique feature of alkanes, that cycloalkanes, that are important to realize as you move forward in your course here. So I've given, the picture here shows the typical cycloalkanes you'll come across from C3 up to C6, but of course you can have more. They can get huge overall, but in most basic courses you won't get much past a 6 carbon chain. Now for naming cycloalkanes, it does get a little bit tricky because of the cyclic nature of the structure. So the rules here, there's 7 steps to follow in order. I'll go through them first and then we'll do an example one. You're going to identify the number of carbons in the cyclic chain. That gives you your base alkane name, in which in rule 2 here you're going to add cyclo to. So as we said before, if we had a cyclic propane, your base name would be propane, and because it's cyclic you would just put cyclo in front of that. So cyclopropane is 3 carbons formed in a circle. In this case, you would show it more as a triangle this way here. So that's rules 1 and 2. Now, when you move to the third rule is when we introduce the idea of a substituent attached to that cyclic chain. If there's only one substituent, there's no need to be worried about any numbering for that. So again, if we took propane and we put a bromine on it, this would just be bromocyclopropane. You don't have to worry about saying a 1 bromo or 2 bromo, what location, because no matter where we put it, actually, if you think about it, it doesn't matter. This molecule can rotate around and numbering is unnecessary. But that's only true if you have one substituent. Rule 4 comes in is what happens if you have 2 or more substituents, and that's where it gets tricky. When you have 2 or more substituents, look at the name of those substituents, and the substituent who is first in alphabetical order, okay, we're disregarding any prefix, a di, tri, tetra, for multiple substituent of that same substituent. You look at the first one in alphabetical order, and you're going to assign carbon 1 to the carbon that that one is identified with. And I'll show you that in the next example. So that will help you when you have two or more substituent. That helps you identify which is your C1 carbon. And then you move on to step 5, where you're now going to number the remaining substituents attached. And you will do the numbering for that based on getting the smallest combined set of numbers. And again, we'll show you that in an example. Once you've done that, now you've numbered all your substituents. You can, if you have a substituent that occurs more than once, you're going to put a prefix on that name of that substituent. And then finally, you're going to list the molecular name for this compound. You're going to list the substituents in alphabetical order. So let's see how that works with an example, and that's probably the easiest way to see how this comes about. So we look at this structure here that I've identified. And again, you start in rule number 1 is what is your carbon chain length that's cyclic. So in this case, you identify we have a 5 carbon chain. This is a pentagon. It has 5 carbons. I'll just randomly, I won't even number yet. So the base here, rule 1, is pentane. We have a 5 carbon chain. And then as rule 2 says, because it's a cyclic, you're going to say cyclopentane. So our base here is a cyclopentane. But we have 3 substituents coming off. And if we look at the substituents, we have a methyl coming off, ATHYL. This here is a propyl, 3 carbon chain. And we also have a 2 carbon chain. This is an ethyl. So when we go back to our rules, we don't have rule 3 because we have more than one substituent. So we do have to worry about step 4, which says when you have 2 or more substituents, identify the one that comes first in alphabetical order. So when we look back at this, alphabetical order, we have a methyl, a propyl, and an ethyl. So E for ethyl is going to be first in alphabetical order. Therefore, this carbon here in the pentane, cyclopentane, is going to be carbon number 1. Now that we've identified carbon number 1, we go to 5 and it says number the remaining substituents to get the smallest combined numbering. So we look here, we have 2 choices. Now that this is carbon 1, we can go clockwise. If we do that, the methyl here would get a number 4. That would be a number 4. The propyl would be a number 5. But if we go in the counterclockwise order, the propyl will get a number 2, which is smaller than 5, and the methyl will get a number 3, which is less than 4. So to get the smallest numbering, we're going to go in counterclockwise order with numbering. So now we know we have a 3-methyl and we have a, use that 2 there, 2-propyl, and the ethyl, as we said before, is number 1. Now that we've identified that, we go to 6, and 6 says if any substituent occurs more than once, we've got to use a prefix, di-tri. We don't have to worry about that because none of ours occurs more than once. And we go to 7 here. Just list your substituents in alphabetical order when you write out your final name. So now we're going to list these in alphabetical order. So we're going to say 1-ethyl is your first. Then the next in alphabetical order is the methyl. So then we do 3-methyl. And then finally the propyl, 2-propyl. And then your base, cyclopentane. It's a mouthful, but because of these complexities, you have to, be aware of the rules, the order that you do them in, and work your way methodically through the rules to end up with the proper name for your compound. And that's true with naming of all the organic chemicals as you get more and more complex. Thank you.